in the exam, very simple. It's assignment 1, 2, and 3. So basically, there will be a question about loads, like specifically about the snow and bonding load and live and dead load. Okay. And assignment number 3, which is about beam checking. So here is one beam and very similar, very, very close to your assignment number 3. Okay. So basically, we will cover assignment number 1, 2, and 3 in the exam. Now, how about the exam itself, how it will be delivered? So I will place the exam as an assignment. So please, when the exam time, you will see the assignment will be released by, I'm gonna release it at 12:58 because I will allow for 2 minutes for you guys to download and probably read instructions. So it's not going to be exactly 1, it will be 12:58 through a D2L assignment, not exam, not D2L exam or quizzes. It is assignment because the assignment is the only place on D2L that I can get your answer back. Otherwise, you cannot do that. So it has to be an assignment. And you can see on my screen, it is bolded, underlined. It's going to be an assignment. Although it is going to be an exam, but you will find it under assignments. Okay. The PDF will be password protected. It means you need a password to open it, and the password will be given to you at 12:58 as soon as you download, and you will be able to open it. However, I don't know. I felt that it should be not be allowed for printing or copying for some security of my exam. So no printing or copying. So please be prepared to read the exam from the screen. The time will be allowed. There will be extra time for scanning. So that's not like when we did the exam back in a time when we did the exam in class. It was only 1 hour 50 minutes, which is the duration of the class. However, for this online education, I give 10 minutes extra, so the exam will be 2 hours in addition to 15 minutes, and those 15 minutes, those are for scanning. So you can scan your 4 or 5 pages and submit them. And I know scanning, it doesn't take 15 minutes, but just in case, okay, so I'm just giving you more or plenty of time. The thing that I would like really to warn you is this. What they do, every one of us would like to be the best, would like to get A+ in the exam. I doubt that anybody would like to fail in the exam. That's not happening, okay? So what happens is students, what they do is they don't watch. They say, okay, I still have time until 3:15. So they keep solving all the way back to back, and then they leave probably 2 minutes for scanning. If you leave 2 minutes for scanning, you don't know what could happen. Maybe your computer will crash, or I don't know. But the thing is, last year, I have seen some examples where students, they failed to submit because the D2L will close by 3:15, okay? And so please don't blame me if you submit your assignment, sorry, your exam after 3:15 by email. I'm gonna be harsh on deduction, okay? So all I'm asking right now at 2 hours, stop, and then scan, and then get ready for submission. And that should be clear from my email, okay? Now, please prepare 10 pages. 10. It says here there is a typo. It says pages. It's only pages. So prepare 10 pages, single face for your answer, like a booklet where you can answer the question. Please also, if you have no scanner at home, which I guess not everyone has a scanner at home, all I'm asking is download any app. I'm not really selling you an app. Any app you like. However, please get comfortable with using the app. I guess a cam scanner or document scanner is a good one. However, whatever you like, use any scanner, but please do not use it for the first time in the exam. That's going to be a fatal mistake. Please ensure that you understand how to scan it. I guess now everybody does because our submission, everything is a PDF file, and probably you've done this already maybe 2 or 3 times, or maybe for other classes, maybe 5, 6 times. Okay. The thing is, guys, there are sometimes people, not everyone has the same computer literacy. So I have seen from this your submission, some they do fantastic job for the scanning. You see a file, you see a good quality for the scan, you see a small size for the PDF file, the scale, everything. I have seen some weird submission for PDF. Oh my God, someone will give you a 2 3 pages and the file is 12 megabyte. I have no idea what they did for that. And also make sure that, I'm going to give you some more details about what the PDF should look like in a minute. But please get yourself familiar with the scanning process. Okay. And also don't make your file protected, because if you make your file protected, it means I will not be able to mark it, and it's very hard to track the grades while on the PDF, I mean, while it's I'm not able to mark it like physically and say here -2, here's -4. Very difficult to manage. So please don't make your PDF protected, please. Now, I always, and you can see that in my assignment, because some people really they don't have computer literacy, and what they do is they send you, let's say, 5 6 images of every page. Like let's say I have 5 pages, they send you five images. No, we need only a single PDF. You can see it is an uppercase letter. It's bolded. I don't know what else I should make myself more clear. Okay, it has to be a single PDF, and the D2L will not allow you to submit more than one PDF. It's only one, so please don't complain. At the end, I need a single PDF file, and here is what you need to make sure before you submit your D2L, and that's why I said 15 minutes. So after you scan, take a moment, open your PDF one more time, make sure that it is legible so I can read. So your answer is legible, I can read. It has to be portrait, not landscape, because it gives me a hard time when I mark and I put my markup on the PDF. The pages will have to be in the right order. So I'm not expecting to see page number 1, then page number 5, then page number 2, and then page number 3. And please make sure the pages are in order. Okay. And again, if it doesn't mean that you have to answer my exam in the same order it was given. Let's say the exam will be 3 questions. You don't have to start with question number 1. Please do whatever order you like. However, when you submit, you just have to order it from question number 1 through 2 through 3, and then probably you need to put your page number at the very end before you scan. Okay. What else on my list here? Please add the page number divided by the total number, because sometimes what happened, I don't want this to happen. Somebody will come after the fact, will say, Tahir, sorry, I had like 6 pages and I forget to give you my last 6, like the page number 6. Okay, you can imagine how difficult my situation, because this is unfair. Huh? You already have like maybe 1 hour extra, and then you're not paying attention. So please, in the exam, say page 1/5, page 2/5, 3/5, and so on. Okay, I think those are intuitive, but the thing is, when I don't say it, people are not paying attention, and even when I do that, I'll find 1 or 2 will not follow. But you just have to blame themselves, not blame myself. Okay. Are you going to watch us? The thing is, I'm not going to watch you guys. We will, all of us, I need to see a 34 students for the entire 2 hours logging in MS Teams. Just like you log in, you turn off your camera and turn off your mic, like you mute yourself, or you will talk and speak only when you ask question. And what happened is, you will also have to raise your hand. I'm gonna allow you, and then you turn on your unmute yourself and then speak. And if there's a common question, if so, everybody is listening. Okay, so I'm not gonna watch you. So you guys are hiding, huh? So don't make use of that. I said I will be available with microphone and camera to answer questions. You will turn off your camera and mute yourself. You only undo that if you have a question after getting my permission, and first to come, first serve. Okay, and please mute yourself unless you need some help. Now, question number 5 is, are we getting, which is very important, very important. I got this question probably 1 or 2 times. Are we getting a review session? So here is the point. I'm straightforward. If you are fair person and you study my material and exam, you will see the exam will be very, very fair. There is no surprise. Anything on the exam, probably you've seen it so many times, if not a single time in my class. Okay? So I don't want to spend hours reviewing and solving a copy and paste of what I've done, because your lecture notes already has numerical example. It's not theory. It is mixed between theory, introduction, and also numerical example. So all I'm asking you is very simple. Maybe watching the video is very time consuming because we've done like, let's say 6 weeks or 5 weeks to the midterm exam. So watching 5 times 3 times 2, this is very time consuming and it's not feasible. So what is feasible is simply reading the lecture notes. And I guess we are both of learning. I guess the best way to go right now is printing your lecture notes, or maybe leave it not printed but take a note on, just like Gord did. You all the time, have some notes on your lecture notes. I think this is the best, and that's what we used to do when we went to the class. When we were in the class, there was no videos, there's nothing. It is me writing on the board, and my students are copying my board into their own lecture notes. Today we have better. We have better now because simply you have a PowerPoint presentation, which I'm doing my best to make it at the best quality I can. So again, uh, print those with your own self notes, and I think those will be sufficient. In addition to solving your assignment by yourself, so you understand what is the process, what are the equations required, and then finally, which I left it for the end because it's super important, make your own formula sheet. Make your own formula sheet. So for example, when we did the snow, we know we have some standard for formulas, some for them with them for roof projection, and another set of equation that is used for multi level roof. Okay, and so please report those or write them in the same order that you use them in a formula sheet. Also for beam checking, we have also some very few formula that we use to solve beam checking. Make sure you create your own formula sheet, and if you have anything to add, okay, for example, let's say for a snow, like for example, the F should not exceed 5. If you remember, the F, the factor in the snow calculation, should not exceed 5. Please make sure that this is clear on your formula sheet. So don't only copy the formula, but also if the formula has some limits like maximum, minimum, make sure that you on your formula sheet you have all of those. Okay. Best one to make your formula sheet is yourself. Trust me, the best one to make your formula sheet is yourself. Okay, and so that's for the preparation. And so what happens, guys? I will be available tomorrow. Tomorrow morning, I have some hours free, and yeah, in my email I said I will be free between 10 to 12, 10 to 12, and I said only. It means only, but I can change that, and it's a discussion right now because I thought about it. If I make myself available from 10 to 12 and you guys have a class that time, it means this is useless. This is useless. Okay, so I'm right now I'm gonna revise that based on your discussion. What hours are you available tomorrow morning between 8 and 1 p.m.? What are the hour or 2 hours you guys are available? Gord,
I'm just looking now.
please.
Um, between 8 and 1 p.m., I've got from 8 till 10 a.m.
Guys, I'm asking you, so please speak out if you don't agree. So 10 is going. I'm gonna change it from 10 to 12. So that's not valid because you guys are busy. I'm going to change this one to 8 to 10. If you disagree, let me know now.
I'll be around for that.
Okay, so it looks like everybody is available 8 to 10. I will come online. We will have breakfast together. You know, I don't have class and it's gonna be like it's not formal. I'm gonna, listen to some music, same as I did this morning. This music I loved so much, so I wanted to share with my beloved students. If you have any question, you will ask me, but don't expect me to give you the exam, huh? That's the only thing. I'm not gonna do that, okay? So if you have any question, how we do that, how we do that, how we do that, I am available, I will answer. So tomorrow from 8 to 10 a.m. And please, after 10, don't ask me. You have to meet me only at 1 p.m. So get ready with all your question tonight. Come tomorrow at 8 and ask those questions if you have one. Some of you, I know some of you, they are very well set up for my exam. So that's good for you. Thank you so much for being a good student in my class. Okay, now let's move on to the last part, which is those are kind of recommendation. It's not something that I'm forcing you. Set up a corner for your exam. If you have one, some people they have place, some people they sleep on the couch. Okay, and that's the only available base for them. Okay, so set up a corner for yourself. Have your laptop and internet connection. Make sure that in this spot you have internet, good internet connection. Prepare those 10 pages like booklet of plain paper or engineering paper. I don't care whether it's plain like white or engineering. That's your choice. Okay. Uh, Make sure you have a scanner next to you or your phone with a scanner app installed. And one more time, you know how to use it properly. And then finally, your formula sheet and course material, whatever you like, whether you like it printed or you like it online, like digital, that's your choice. It's not my choice. I have no control over that. Okay, guys? Any questions so far? Hopefully that my email gives you kind of a full picture of what the exam will look like in terms of administration, in terms of content, assignment 2 number 3, there is no surprise. If you have assignment yourself and you really understand, and I say one more thing, and it has to be clear. My exam needs somebody who is smart. When I say smart, it means I'm not saying what they call genius, smart. It means vigilant. It means when you look at the problem, please don't jump right away and solve it. Please give yourself 1 minute, because this one single minute, it can save you ton of time. Okay, ton of time. Look at, for example, if I gave you a beam section, look at the rebar. My rebar is symmetric or not symmetric. If it's symmetric, you guys know where is the centroid. If it's not symmetric, then I know what to do to find the centroid. There was a very common, like look at the assignment number 3, look at my feed and mark up for you. Some of you use the centroid in the middle, while in the assignment it is not in the middle because it is not symmetric. Okay, and remember, when I say it's not symmetric, I'm referring to the number of bars and bar diameter. To say it's symmetric, to say my rebar is symmetric, it means they have to agree in number and agree also in bar diameter. So if you have a change in bar number or bar diameter or both, then it is not symmetric, and you have to find the centroid using what you learn in strength of material and even this here with me early on in my class. Please be observant. Okay, don't just right away, you know what, here is here is the problem, 1 2 3. Think for 1 minute before you answer, because it will save you whole bunch of time. And so some of you will say, okay, the exam is fair, it requires less than 2 hours. 2 hours is plenty of time. And some of you will say, oh my god, he is crazy, this guy's crazy, he's giving us an exam that takes 4 hours and he needs us to do it in 2 hours. Okay, I'm not crazy. Okay. Okay, guys, let's move on. Any questions so far? Any questions so far?
Not so
Okay.
far, no.
Okay, great. So let's move on to our class today. So I have my presentation, which I started the last class, and the example, which was kind of roller coaster, where we have to iterate and go back and verify this and verify this, so it doesn't work. No, let's change that. And that's a good example to prove that the design process in general, it is not a linear process. Do not work, we have to refine them and do some kind of iteration, internal iteration. Now, guys, so where we ended up last class is somewhere here, okay? So this is where we ended. We talked about, uh, you know, the how to do the beam design and also how to do crack control. But the thing is, there is something I kind of never covered, and that's why could you please download my latest set of presentation like this one right now, because there are few pages added, and again you will understand why I added those. Okay, now let me start here. You guys know this number here? What is this number? Can anybody tell me what is this number? I'll zoom in. Look at
The
my
moment
screen.
force.
Excuse me.
The moment force.
Actually, there's nothing called moment force. It is called factored moment. So this F over there, it is referring to the factored moment, because you can see we factored our loads. And so we're using here our factored load, and what we get is something called factored moment. Okay? So guys, in plain English, what do you mean by moment? It is the moment that is going to affect or act on my beam under factored load. So what is my job in my design? I need to make sure that my beam is strong enough. When I say strong enough, it means the capacity of the beam will have to be equal or more than this number. That's something we said it several times in my class so far. We have to make sure that M sub R, which is the moment of resistance or the capacity of the beam, exceeds or equal my MF. And I always start with MF is equal to MR, if you're following. And then when I say MF equal to MR, I can use the same number here to find the amount of steel. And that's what I did. The amount of steel was this much, which is 5,367. And then what happens? I went through iterations, not only one, probably there was few iterations here until I'm able to make sure that my beam is working. At the very end, I used 1225 M, and so those are 6,000 square millimeter of rebar, and the required area of steel is simply 5,077. So you can see so far we have two moments. One, it is called M sub F, which is factored moment that will affect your beam. And the other bending moment is called M sub R, which is moment of resistance, which is the capacity of the beam. Now, guys, remember I said along the way, so yes, we start from the equation MF equal to MR. So I will start with making the capacity of the beam is factored moment. However, what I do, I will ensure along the way that my moment of resistance or the capacity will never fall below MF. How? One of the things is we need to provide area of steel always more than this number. Always has to be more than this number. Okay? The actual area of steel, it has to be always more than the area of steel as per the equation. Number two, for the lever arm, I have to make sure that my actual lever arm has to be more than the assumed lever arm. Those are the two things will ensure that your moment of capacity of your beam will exceed the factor moment, so we are on the safe side. Following so far? Are you following this discussion? I need to hear some noise.
Yeah, we're following. You said there was some new slides added to that one.
Exactly. So here we go. So you can see I added one slide here. And please, when you look at this slide, there is nothing new. There is nothing new. So we started from a moment from a beam that needs to have a resistance. Remember, I'm gonna remind you, what is the number? The number was 689.5. Okay, the beam is supposed to do that. However, as I added steel more than required, make sure that my lever arm is more than required. So what do you think about the MR? Is it going to be exactly this number, or will be more?
More than MF, my MF.
Exactly, guys. So the last slide here, which I added for every example that I have solved it so far, and I will show you where. So for this example, what I did is I exactly did what you will do tomorrow in my exam. It's a check problem, where what I did is I simply found, because my beam is already designed, so I know how many bars, I know the beam section, the shape, the dimensions, everything is known. So I'm gonna do check beam checking to find what is MR, same as we have done in number 3, okay, which will be examined tomorrow. So I go ahead and find my A. What is A? Is the depth of equivalent compression block, which is, please say it with me, say it with me. This one is phi S, 85%. This number is F yield, 400, okay? And this number is 6,000, which is 1225 M, okay? So phi S multiplied by F yield multiplied by area of steel divided by alpha 1, it's 0.8, phi C 0.65, and then 30 FC dash, and then the width of the beam is 450. I get this number. And remember, in this case, you don't have to worry about is it tension or compression. Do I have to do that? Anybody is following? Do I have to say right now that my beam is tension or compression or balanced? What do you think?
No, no.
No. Why? Because I already, look at this, that's my design. I already made sure here before I finalize my design that my beam is a tension failure, which means don't waste your time. It is a tension failure without you doing this, because that's what you've done here. Next is you find the moment based on tension and based on compression. And please, in the assignment, I think only few, very few, 2-3 students or groups, they found the MR based on tension and based on compression. Few, only 2 or 3. So only 2 or 3 groups are reading my notes. Okay? Most what they did is they say, here is my MR, 0.85 times 400 times like phi S F field area of steel multiplied by D minus A over 2. Please, you need to find the MR from tension and compression, because simply you can see if I do it from tension and compression, guess what? I get almost the same number or sometimes the exact same number, okay? And this gives me a mathematical check that I have never done any mistake for the area. You know what? You don't believe me. I myself was trying to come up with these slides, and I have myself done so many mistakes. And the only way I know my mistake is when I found my moment from tension and compression, they don't agree, so I know that I have a mistake. What I do is I go back in 1 second, I check my A, and I found that A, yes, it's not true. It's I just hit one wrong number on my calculator, and I got wrong number for A. So please don't do that. You have to estimate your MR from tension and from compression, and they need to agree to a certain level. When I say to a certain level, it means, let's say 0.1, 0.2 kilonewton meter. But if you see there is a 20 or 10 kilonewton meter difference, it means there is a mistake here. Where is the mistake? It's in the estimate of your A. Guys, look at this, please. So now we can see my moment of resistance is 759.3 now. And remember, originally my moment, I'm sorry, I have a mistake here. So guys, this is a mistake. I'm sorry, I will have to change it. So my MF really is here. It is 689.5, which is I estimated from here. Huh? So this is my moment. So remember, I need a beam to resist 680.5, but finally, when I finalize my design, my beam is going to resist this much. So we simply, if we're able to find the ratio between MR and MF, which is simply 759.3 divided by 689.5, I get 1.1. Let me ask you, What happens if this number is equal to 2.9? What do you think?
That means your MF is higher than your MR.
Yeah, what does this imply? What does it mean?
Your system cannot resist the load. That means it's unstable.
No, sir. No, 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 no. You're confused. You said something very nice, and then you followed by something is not right. So it means yes. It means it's unsafe. Okay, but the word stable and
Unsafe.
unstable.
Unsafe. No, I'm sorry.
Unsafe, not
Miswording.
unstable. Those are two different
Yeah,
names and they're
unsafe.
not the same. So your beam is still stable, but it's unsafe. It means if you arrive to this level of load that gives you 689, it means your beam will fail. And that's why this ratio, it's called utilization ratio. And simply, it is the ratio between your MF or MR divided by MF, or actually, to be honest, you know what? Like, because this is not really a very common concrete terminology. You do that in steel, huh? So in steel, it's the reverse of this ratio. So the MF is over MR. So I don't think probably I need to revise that. We don't call it utilization because MF is over MR is the inverse is the utilization ratio. But I would say here, everything here is still valid. So if I get 1.1, what does it mean? It means I have 10% reserved capacity because my beam can take 10% over the MF, which means, let's say somebody else in the future came and say, Tahir, I want to add a rooftop unit. My beam is still okay. Well, if this rooftop unit is going to produce or generate a 5% extra, I'm okay because my beam still can survive for 10% extra on top of your MF. Okay, so guys, again, you can see there is still typo. This is going to get better and better. So this is wrong. Like the 80, it's supposed to match the 689. Okay, and this is not called the utilization ratio. The inverse is called utilization ratio. Okay, I'll think about this name and I'll come back with a good name. Okay, but again, what I did, every problem we've done so far we've done 3 problems. You will see I have added 1 page like here. It's over there, huh? So this is the how to find the ratio for, and again, look at this, another typo here. So that's not 800. So simply I found my MR, I started MF, and we have here only 4% reserved capacity. Okay, for question number 1, here we go. Somewhere here, I added 1 page to find how much reserved capacity do we have. Somewhere here. It's over there, okay? And that's the only time your 800 is correct. So this number is correct. I just copy and edit, and this is your 800, and this one is perfect. Anyway, you get the idea. The idea is because we start from MF equal to MR, or sorry, MR equal to MF, and along the way, I make sure that MR will never, ever, ever fall below MF. Otherwise, it's unsafe design. So what I do is I go back quickly and I'm able to find the MR. The MR over MF should be more than 1. Should be more than 1. Okay. So guys, let me ask you a few things here, please. Okay. What if the R over MF, this number happens to be 2? Let's say this number is equal to. What do you think? Is that good design? Is it safe or unsafe first? Is it safe or unsafe if you divide your MR by MF and you find it's 2? Is it safe or unsafe?
Unsafe?
2 is unsafe. If you have a 2, again, please forget about this word because I know that this is wrong. Utilization ratio is not correct. Okay. I'm saying MR, so the MR over MF is 2. It means MR is twice MF. My beam capacity is 2 times the applied moment. So we have 100% reserved capacity. It means what? It means my beam is safe. But although it is safe, it is what? Is it a good design or bad design?
Overly designed.
Overly designed. That's overkill. We added so much rebar more than we should, or maybe added so much concrete more than we should, because we have capacity twice as much as the MF. Okay, guys? Guys, I guess there is a very similar discussion in your steel course you're going through right now. But I guess in Corwin, what he does, I think the opposite. So you look at MF over MR. And really, MF over MR is called utilization ratio. The MF over MR. I'm going to have to come up with the name, this name for this ratio. Huh? But the opposite, like the inverse, is called utilization ratio. For example, in this case, probably it will be 90%. It will be 90%. It means my MF over MR is 90%, which means I'm using 90% of the beam capacity. That's very, very common in steel. After you design, you find something called utilization ratio, which tells you how close you are to 1. Best design for utilization ratio, if you are very close to 1, it means you're using the best of your material. Okay, are you guys following so far? We have Gord. Gord, you have your hands up.
Sorry, accidentally hit the button when I was moved to go put printer in the paper.
No worries, sir. Okay, so guys, so now we can see here is how those are the few pages I added, so you guys are aware of why and where. Now I'm gonna show you something very, very interesting. I'm hoping. So we've done this example here, and every time we need to find area of steel, we go this way. So I derived this equation for you guys. If you remember, we derived this equation in our class. So every time I want to find area of steel, I use this equation. Is that the only way I can do that? Not really. There is another way which will be discussed now. So guys, look at this, please. So this is the new method that I'm going to show you. And in the beginning, I know 100% this will be kind of difficult to understand, but this will be our way to go in this class. So this is an alternative to the equation. Instead of us using this lengthy equation like 0.0015 F prime C and so on, we have another method. Where is this method? Where it came from? Nothing new. It came from the same equation that we did, but instead of solving for the area of steel, we solve for rho, which is reinforcement ratio. Now let me show you how this method works. This method requires a minimum math, unlike the FC dash, the 0.0015 FC dash B minimum math, and I will show you how, and I will show you why it's a favorable or favorite method. Now, so we have some tables here, and to find the area of steel, we will use those tables. Okay, those tables where they come from? They come from the manual. So the manual, if I zoom in, you can see it's over here. It's table 2.1 on the manual. So the table here is simply lots of numbers, but I will show you slowly what or how to read this table, how to use it. Okay. So guys, the table comes in columns. So the first column here, it's about KR. Okay. And what is KR? Probably need to zoom in. So this is my KR. And what is KR is simply here. The moment of resistance of your beam is equal to your KR multiplied by B, the width of the beam, multiplied by D squared, which is the effective depth squared of your beam. Now, next is there are so many columns, and every column of the table, it corresponds to FC dash value. So the first column is 20. So this entire column is for FC dash called the 20 MBA, and 25 all the way to 60 MBA. How about the rows? You can see my first value for the K is 0.5, and then the table is built on interval of 0.1. So 0.5, 0.6, and 0.7, 0.8, 0.9. And the table is not only one page. So on the right here, that's page number 1, and which ends at 2.9. So the last value in the table is 2.9. And then page number 2 starts from 3. So I'm going to zoom in here, not very clear, but this is 3. and keep going all the way to and the end of page number 2 to 6.4. Okay. Now, how do we use the table to design my beam? And to be honest, I wanted to show you how easy to do that. So I give you, or I use exactly the same problem we've done before. Okay, so what I will do is I'll go up, and remember, look at this, please. Look at this, please. So you can see here, how much is my moment? Is 689.5. That's MF. Okay. Now, what we did is we simply found our D based on the assumption that 70 millimeter. And once you find your D, use the equation to find the area of steel. Now, what I'm going to teach you is we're not going to do that. I'm going to show you how to use the table to simply find the same amount of steel, but in easier way. Now, what you have to do is watch this, please. I'll zoom into the left side. So here is my same information. Here is my moment, which is 689.5. Here is my width of my beam. Here is my depth of my beam, effective depth. And here is my FC dash. Here is the steps you have to find area of steel. Very, very simple. And it involves way less mass than the equation. All you have to do is you say my moment, M, divided by the B times D squared. There is nothing new. Okay? It comes from this equation here. If you're telling me that my moment equal to K times B times D squared, so how much is my K? K is equal to, you rearrange the order, like the order of the formula. So the K will be M divided by B divided by D squared. Okay, watch this. So we'll do it here. We'll do it here. So moment, which the moment, the MF, divided by the width of the beam here, that's the D, and this number, sorry, this number is D squared. The only tricky part here is, since everything is in Newton and millimeter, then you have to multiply the moment by 10 to the power 6, 10 to the power 6 for the units. And what you'll get is 5.72. 5.72 is going to be in MBA units, MBA units. Then you take the K into the table. Look at this, please. Please watch me so you can see. I'm going to go with the K into the table. Watch this. So I'll go from 5.7 and I will go here and I will say, you know what? The 5.7 is somewhere between, the 5.72 is somewhere between 5.7 and 5.8. Guys, since the table is simply provided on a 0.1 interval for the K, what I can do is I can do linear interpolation, linear interpolation. So you can see here the 5.72 is in between 5.7 and 5.8. So what you do is you go horizontal. Once you go horizontal, which column you're going to hit is the column for the FC dash. Please watch this. So on the top here, my FC dash is equal to 30. So look at my arrow. Look at the arrow, the blue ones. I go on the column of 30. And I go on the row for the K that I got from this equation. So simply your K is equal how much? Not very difficult. You interpolate 5.7, 5.8. You simply interpolate between 2.2 and 2.26. 2.2 plus 2.26. So my number will be in between those two numbers. So I did the interpolation, and guess what? I got 2.212. So guys, what's this number? What exactly this number is? It is the reinforcement ratio. So the table will give you the reinforcement ratio on your beam. If you're lucky, then your K will be 5.7 or 5.8. If it's 5.8, great, you get 2.26. If it's 5.7, you get 2.2. If it's in between, you do linear interpolation, and you will find number in between 2.2 and 2.226. So my number is 2.212. And then finally, if you want to find area of steel, very simple. You take the reinforcement ratio, because that's by definition. The reinforcement ratio is the ratio between area of steel divided by B times D. So if you know the reinforcement ratio, you multiply times B times D, you will get the area of steel. Okay, the area of steel. And remember, the area of steel is 5151, And when I did that using my formula, please watch this. So here, look at this, please. When I use my moment, here is my moment, and here is my width, my depth of the beam, 517.5, and then here is my B. I got 5077. However, from the table, we got a little bit different number. We got 51. So you can see here, that's from the table, and this is from class derived equation. Okay. Now, why there is a little bit of difference? Or let me check first. Are you guys following? Are you following?
Yeah, we're following.
I know in the beginning it looks difficult, but I will tell you this will be our favorite way to find area of steel, because simply the formula, it's a very lengthy formula and it requires lots of math. Okay. Anyway, I'll give you this 1 or 2 rounds and you will see it will look even better. Nicholas.
For using the tables, why do we use linear interpolation instead of just going to the next higher number like we do in steel to be on the safe side?
Good question. Good question. I'll answer this one shortly. Jelly.
Yeah, then which one you prefer? The one in the class calculation or this a table? Which one is more accurate?
I'll exactly, good question. I will answer both of them. I'll answer Jelly. I will answer Nicholas. Very good questions. Thank you so much. Thank you so much. So I'm gonna start here. I will start here probably with Jelly, and then I'll go for Nicholas because there is an order for of the information in my head. So Jelly is asking which one is more accurate. Okay, so the answer is, do you guys remember? Do you remember when I derived this equation in class? Why I came up with this 0.0015? Does anybody remember how did I get 0.0015? Maybe you cannot remember, which is okay by me, by the way. You guys remember when I did the derivation, there was something called alpha 1, and there's something called F field, and there is something called beta 1. And alpha 1 and beta 1, those are the transformation from parabolic shape into equivalent rectangular block. And I said in the code, we need to estimate alpha 1 and beta 1. And what happened is, so there are some equations in the code to find alpha 1 and beta 1. However, I said in my class here, since all the time the FC dash will be between 20 and 30, so the 0.8 and 0.9 is a good approximation. I need some noise. Do you guys remember that, or nobody remembers that?
Yeah, I remember that.
Yeah. Okay, excellent. So guys, what happens here? The table doesn't do that. The table, please take a look at the very top of my table. You can see here, the table simply estimates a value for alpha 1. It's over here. So this is alpha 1 and then beta 1. And you can see the alpha 1, it goes from 0.82, 0.81, 0.81, 0.8, and then at 40, it goes to 0.79. And as I said, it's very close to 0.8. How about beta 1? For FC dash equal to 20, 0.92, 0.91, 0.9, 0.88, 0.87. And as I said, we can use an approximation of beta 1.9 in my class. So now let me ask you one more time, Jelly. Which one you think is more accurate? The formula or the table?
The table.
Okay, is everybody got what Jelly just said? The table is more accurate because it uses the exact value for alpha 1 and beta 1, not as we assumed in my class. But by the way, this doesn't make the formula bad. All we have to do is, if you are interested, you can use the same formula, but don't use it in the if you want to use the formula exact number, you need to spend some time and don't use this simplified form. You just have to go to the original form before we replace the alpha 1 by 0.8 and beta 1 by 0.9, and you will see you will get exactly the same result because they came from the same mathematical base. So that's number one. Did I answer the question, Jelly?
Yeah, but I'm confused now in the beginning then, because when we go calculate something else using alpha and beta before going to AS, then or maybe in some other situation, but in the beginning, when especially when we calculate the CR, when we calculate CR or TR, are we gonna use also, or only in this finding the area of steel, are we going to use this table, or in some other like CR, TR, we also have to use a table for 0.92 or assume 0.9, 0.8?
So you are kind of confused because we're talking about design and you are referring to the check. So we do the CR and TR when we do the check, right? So you can use the table, and I will show you this in a minute, that we can use the table for also for checking, okay? But in general, really the formula or the table, they come from the same origin. So they're supposed to give you the same results. However, I need to use the exact value of alpha 1 and beta 1, not approximation. And I can tell you the difference is insignificant. So please don't ask this question to me. Both of them, they give almost the same results. Please don't think about this is significant. This is how much difference is a 50 or 80 square millimeter of rebar, and that's very, very little. Very, very little, okay? Hopefully this answers the question for you, Jelly. Now let's go to Nicholas. So Nicholas said, you know what? Maybe in other courses, we don't have to do linear interpolation, and we can just go from 5.7 to 5.8, and we pick 2.26, and then we simply, this will be our reinforcement ratio, and then we use it in this equation to find area of steel. You know what? Here is the answer. The correct answer is do linear interpolation. However, if you also use 5.8, this is also correct, but you're kind of saving your time, huh? You're just trying to avoid the interpolation, so you just save some time, but you wasted some material. Okay. Hello, Nicholas. Did I answer your question? So I mean specifically, yes, you can forget about the linear interpolation, and you can just round your K up, and it means you get a little bit more area of steel more than you should. Okay, Gord.
So for the area of steel, like on the exam or whatever, if we use the formula or the table, we should still be okay to use either one?
I will force you, sir. I will force you. I will force you, because again, that's exam. In real life, your question is very legitimate question. In real life, both of them for me is acceptable as an engineer. Okay. However, in the exam, because I want to examine you and get one number, then I will force you. I will say use class derived equation or use table. Okay. So I will be very specific to remove any confusion and get one model answer. As I said, otherwise I will have to get so many answers, and this will make my life difficult. Now,
okay, so no matter what, you'll specify what method to use.
Yes.
Okay.
I myself as an engineer, I use all the table. You know, the formula is mathematically involved, like lots of math, like square root and square and square root and bracket, and it's not easy, and you will see it takes you more time. Once you get familiar with the table, the table is super easy. You find the K, you go into the table with the K, you get the row, you multiply the row times B times D, then you're done. Very, very quick. It's a division, and then find row, and then multiplication. There is no square root, there is no power, there is no subtraction. Look at the equation and you will see what I'm talking about.
Okay.
Jelly.
Yeah, I also wanted to add something about if you bring up the value for KR to instead of 5.7 to 5.8, you may end up probably over design. Is it?
Not, you know, not much. And you know what? I myself, like, you know, created for myself, and that's my own effort, and I can share it with you guys. I created myself like a equivalent table like this one. I call it Tahir table. And guess what? In Tahir table, the resolution of my K is even better. It is 0.05. So in my table, which I can share with you guys, it is simply, it goes from 0.55 to 0.55 to 0.6 to 0.65. So it has 0.005 interval. Again, guys, please don't get distracted by, you know, those kind of discussion. Again, if you have no time, if you have time, do linear interpolation and try to become a good designer. If you have no time in the exam, probably you can round your K to the larger K. If it's in between 5.7 and 5.8, if you use 5.8, obviously, look at this. So when I did linear interpolation, I got 2.212. When I just saved my time and I used larger K, I got 2.26. And for sure, if I multiply 2.26% multiplied by B times D, I will for sure get a little bit more number than 5,151. So a little bit of waste, but remember, you always have to pick among standard bars, which means what you will do, you can see, remember, I added 6,000. Remember, because I'm using 25M, I ended up with 25M, which means you can see even those little changes, it doesn't affect your results. Are you guys following?
Yes, okay. So still the same thing, because no matter what, you're still gonna get 6,000 anyway for your total area.
Exactly. Okay, so even those things, we know what's true. What's correct is linear interpolation. That's correct. Nobody can say linear interpolation is wrong. However, if you have no time and you know that if you do not do linear interpolation and you go with the larger K, then you'll end up with a little bit more area of steel. Okay? And again, remember, at the end of the day, you pick among standard bars, which means probably you will add any way to whatever you get from the formula or from the table. Okay. Any questions so far, guys? Any questions so far? Okay, so in the next couple of minutes, I will show you how to use the same table. So remember, the way I showed you right now, we use the table to do. Are you guys following? So far, I showed you how to use the table to do a design. Number one, here is the steps. You have the moment. So what you do is, and you have the B, and you made the assumption of the 70, you have the D. Then you just divide your moment, divided by B times D square, you get K. In the table, you go vertically on the column of K until you find the K. And then you turn right, and then you hit the column where the FC dash is of your beam. And then you find the reinforcement ratio rho. Then you take the rho, multiply by B times D, you find area of steel. That's called design, not checking. Now, in the next slide, which shouldn't take long, I'm gonna show you how to do a check for your beam. Check. And what does it mean, check? It means, here we go. It means, here's my beam. So guys, hopefully by now, everybody in class knows the meaning of check. It means my beam is given to me. Look at this, please. And this problem is not new. This problem, we have solved it in our lecture notes. If you go back to where I covered the beam checking, I have exactly the same problem here. Now, please look at the procedure. So if the beam is already there with dimension and rebar, then guess what? I can find my rho, my reinforcement ratio. Okay, how? Very simple. Look at the beam. We have 325M. So the area of steel is 3 times 500. And you divide by the B times D, because that's rho by definition, huh? Area of steel divided by area of concrete. Guess what? I got 0.58%. So that's my reinforcement ratio. And look at this, please. So the way I use the table, look at the direction of the arrow here. So, and look at the direction of the arrow over there. So what you can see is, I went on. I think there is some. I'm sorry, guys. Looks like a something was moved around, and I need to change that. My shaded area is not right, huh? Remember, my arrow, it's supposed to be here. Please forgive me for that, okay? So my arrow is here. So you go along the row, the FC dash of 30. You keep looking at the number. We start here from 0.15. And then I go all the way down until I find my 0.58, which is here, huh? 0.58. So you can see here, 0.58 is between 0.56 and 0.6. Between 0.56 and 0.6. Okay? So you go horizontal, which means my K is here. My K is in the middle between 1.8 and 1.9. Do you guys see that? I need some noise, please.
Yeah, we
My
can see.
reinforcement
Yes, yeah.
in my beam is 0.58. So again, this shaded area is wrong. It's supposed to go around FC dash 30. So I went along the column 30 and I went all the way down until I figure out, you know what? Here is my reinforcement ratio 0.58, which is exactly in the middle between 0.56 and 0.6, which means my K will be exactly in the middle between 1.8 and 1.9. So which means 1.85. And then finally, you use K moment is equal to K multiplied by B multiplied by D squared. So you get the moment here of 312. And guess what? When we did this manually to find, you know, how much is my CR, how much is my TR, how much is my A, then I got 310.67. Please go to your lecture notes and you'll see this number, huh? Not this slide, the other slides. And you can see the two numbers are very close. Which one is more accurate? This one is more accurate. Why? Because we use the exact value for alpha 1 and beta 1. Now I need to ask Nicholas. Nicholas, are you still there?
Yeah.
Okay, so I have a question for you.
Oh boy.
Oh, that's okay. Don't be scared. I'm not gonna bite you. Just use your brain, huh?
I'll
So,
try.
so Nicholas said here, Tahir, why don't you forget about linear interpolation and simply go ahead and use the bigger number, 5.8. You get 2.26 and use this number. We know that we can get a little bit larger area of steel, which is okay, huh? Now, can you do the same thing here? So my reinforcement ratio is 0.58. Should I round this 0.58 to a 0.6 and then I got 1.9 and then I take the 1.9, I multiply the 1.9 times B times D square, I get MR? What do you think? A question for you and everyone. If you know the answer, show your hands. Remember, the process here is reversed. We're not doing design, we're doing checking. So I'm asking you here, should we completely ignore or can we ignore the interpolation and I can use the larger K and I find my MR? What do you think? For marks, not free. Show your hands, please. And then we're gonna take a break, huh? Okay, let's go with we have 2, 3. Okay, and I will listen to all of you guys. So I'm gonna start with Jelly on the top of the left here.
Okay. I would say interpolation should be important because you are checking if the if what you have if your system is safe or unsafe. So it has to be important that your MR must be accurate.
Okay, so I mean, okay, so although this is my question, but I will consider this as an answer. Okay, Gord, what do you think?
I think to use the table with the larger is okay because it's just a check.
Okay, how about Nicholas?
Well, you said that if you use the table or interpolation, you should be able to get the same results. So, would if you use either one, you should get similar, right?
Okay, guys, my question was really so. Jerry answered implicitly the question, but my question is about so okay. So interpolation is the right way to go, huh? So let's agree. Interpolation is the right way to go. But my question is, what if we forget about interpolation? We want to save some time. When I did the design, I went with the larger K, When I do check, should I go with the larger K or the small K? It means, guys, here is my question, very, very specific. For that design, what I did is, or what Nicholas suggested, forget about interpolation, take that 2.26, and then, sorry, take the 5.8, I'm sorry, take the 5.8, not 5.72, and then head horizontal to the right, and then take 0.26, forget about interpolation, which I agree. we will get a little bit extra of steel, which is fine. How about for the check problem? And if we would like to ignore the interpolation, interpolation is the right way to go, no question asked, okay? All the time, interpolation is correct. My question is, if I want to bridge the interpolation, ignore the interpolation, okay? And you can see here, I have my 0.58 is here, in between, okay? Well, if it's 0.56, problem solved, because simply my K is 1.8, no doubt. But my question is, if my rho is 0.58 in between, and I don't want to do interpolation. My question is, should I use 1.8 or 1.9?
1.9.
Okay. Okay, so let me first of all okay, Nicholas, do you want to say something?
My answer is same as Gord.
How about Jelly?
Yeah, I'm still gonna go with interpolation, because otherwise, if you will use one.
No. Interpolation is the right way. That's not my question.
Okay.
My
Yeah,
question
yeah.
is,
I
if
will
we
go
want to
with.
forget about interpolation, we're not
Okay.
gonna do it for the sake of
Okay.
time. That's it. What we
Okay.
should do, should we go with the 1.8 or 1.9? That's my question.
I will go with 1.8, because
Okay.
if you go with 1.9, that means you may end up, your MR is gonna be higher than the MR you calculated.
Okay. Listen, guys, would you be happy if I gave you 5 marks, Jelly?
Thank you so much.
So Jelly said it right. You know, here's the thing, guys. Guys, look at this, please, and the number will tell you. If I just use 1.8 when I get my MR, it means I'm going to get a conservative number for my MR. Conservative number. Okay. If I use 1.9 for my K and I use 1.9 here, what happens is I'm going to get a more resistance. That's what my beam will do it. Okay. The true number is 1.85. Let's do that. So based on 1.85, guess what? I go 312. Can you please somebody help me and use 1.9? So somebody please help me. I'm going to show you. Now, what if I say, you know what? Forget about interpolation. I use 1.9. Okay, so 1.9 times 400 times 650 times 650. This will be the moment based on my guess, or my being lazy, and I don't want to do interpolation. So I used 1.9. I follow Gord and I follow Nicholas. I'm using 1.9. So
You
what I
get
get? Anybody to help
494.
me?
494.
494?
Yeah.
I don't think so.
I
That's
got
too far.
321.1.
Yeah,
Yeah.
321 is a good number. It's a good number because it has to be close. And look at this. Look at this, please. So let's agree. What is the real capacity of my beam? What do you think? 312.65. While me as a designer, I say, you know what? My beam can resist 321. What do you think? It means I'm so optimistic. While my beam, we cannot do the 312, 321, but it can only do 312. Now let's go with the other option. The other option is, let's do this one. So go 1.8, multiply by 400, multiply by 650, multiply by 650. How much is that?
4.2.
304. So here is what you have to do. You will tell your client, my beam can only resist 304. Okay? Which one is better? That we know how interpolation is the right way. Which means we know that my beam can take only 312. So two options. If I go with 1.9, I'm going to tell my client, your beam can take 321. And if I go with 1.8, I will talk to my client and I will say it can take 304. Let me ask you now one more time, which one you think is going to be right? If you tell your client your beam will take 321, while in fact we know it's going to only carry 312, that is called, I don't know, it is called optimistic, and that's unsafe to tell them. You're telling them your beam is so strong while your beam is a little bit weaker. What should happen? You should tell your client this number. You should tell your client no, your beam can take only 304, and you know that is going to take a little bit more because of your laziness. And hopefully, you guys, I follow the discussion and agree, huh? Let me get Gord and Nicholas to agree or disagree. What do you think?
Yeah, I
After
agree.
this discussion?
Yeah, I agree. It makes sense now.
Yeah.
I thought it was just to check it to see if it would take it, but if you're putting it as you got to explain it to the client, then yeah, that makes sense to err on the safe side.
No, remember what is the meaning of check? The meaning of check is there is an existing beam, and we would like to see if this beam is going to be safe or unsafe under loads. So I guess it's a safer assumption that your beam is going to take only 304 instead of assuming that your beam will take 320 something, because we know it's going to take only 312, because that's based on linear interpolation, which is the exact method. Are you guys following so far?
Yep, that makes sense.
Okay, guys,
Yeah.
so I know that I went a little bit over time. Really, my plan was to simply finish everything for today, but we'll see how we progress. We're not in rush. We'll take 10 minutes a break. We'll come back and see what can we finish. Thank you, and I'll see you in 10 minutes. 9:23. Thank you.